about Max 2021 rendering and viewport features. The first thing you'll notice with 2021 is that all the defaults are new. First time you launch it, you'll be presented with this dialog informing you of this. And when you start Max, you'll find that if you're a user of the old material editor, it will come pre-populated with the physical material everywhere. This is an accurate, high-quality PBR style material that works in all renderers and has a very nice representation in the viewport. It has really cool presets you can choose, like here we're picking gold, and should really be your go-to material everywhere. If you're using SME, well, it doesn't come pre-populated per se, but if you pick something like the double-sided material, you will now find physical materials pre-filling it. The physical material UI has been completely rewritten in Qt. It's pretty much the same as before, but much faster and much nicer. The other obvious change is, of course, that Arnold is now the default renderer. Arnold is a modern ray tracer, unlike the old scanline renderer, and it's a fast, accurate, physically based production quality renderer. As you see, the material renders pretty much the same in the renderer as you see in the viewport. The rendering can be completely interactive when you're running Active Shade, and of course it works in the in-viewport Active Shade 2, where you're working directly interactive with the rendering itself. Using Arnold need not be difficult. We can try just hitting the render button and using the defaults, which generally gets you pretty far. This is now a CPU rendering. Arnold supports a GPU as well, and this particular thing rendered in 22 seconds. Now let's compare this to the old scanline render, which I hear sped up 10 times, so we shouldn't have to wait so much. Actually, we still have to wait, because scanline is wholly unsuitable for modern physically based rendering, which is why we're making Arnold the default. And if we see, scanline doesn't even do glossy reflections, so this took over 3 minutes and didn't even render the correct thing. Now, if you want your Max to behave the old way, just pick Max Legacy in the default switcher and you're done. A lot of work was also put into the viewport. Here is a 21 million polygon mecha thingy, and we can see the nice shadows you get from the progressive skylight. But the fact that it renders progressively is perceived to be annoying by some. It might be distracting. So we actually made this optional. It is the progressive skylight feature, which we can now turn off. And we see the object is still lit by the environment, which we can demonstrate here by rotating the environment map or picking a different one. So that is still the case, but you don't get the progressive shadow. It's kind of like turning shadows off, but not exactly. Of course, the image is much nicer with the shadows. So how can we have shadows and not the flickery behavior? Well, we improved the ambient occlusion. So now you can turn on ambient occlusion instead of the shadows, which gives a similar effect and does not have any of the blinking behavior. So it can look really, really nice and completely interactive. Remember back to 2020, it could do ambient occlusion, but that was also a progressive effect. It was also a worse looking algorithm. The new AO is a different algorithm that is instant, does not need to be done progressively, and basically looks much better than it did before. We also included a very cool OSL HDRI environment shader. Has some simple features like being able to rotate the environment around the Z-axis, but we can also push it up and down and tilt it around the X or Y-axis. It does exposure, where you can change the brightness. There's a way to tweak the contrast, and you can even do clamping, although it doesn't do much in this image. The shader also supports background blur, either just as removal of distraction or to fake depth of field. Another classic problem with HDRI environments is that if you start zooming in and out, it looks like your object is shrinking or growing, or if you're panning around as it's flying in some weird direction. There's no connection to the ground. To avoid this, we can turn on the ground projection. This flattens the bottom of the environment map and basically plants the feet of our object on it, and now it looks like it's standing on the ground rather than flying around. And when we zoom in or zoom out, it looks correct. All these features together makes it really easy when the director tells you, I want my battle robot by the lake in the sunset looking sad. So you can just get yourself a lake environment map, you can tweak the colors to a nice sunset look, and boom, you are done. And you didn't even hit render. Here's an astronaut model downloaded from TurboSquid with the PBR setup slightly tweaked for this example. If we compare the viewport here to the rendering, we'll see that the main difference really in this case is the rendering has real reflections. You can see the helmet camera being reflected in the helmet, which you can't do in the viewport. That's almost the entire difference. The key here, you can do look dev decisions already in the viewport completely in real time. So let's go to Mars. We put our astronaut in a desert environment map, sunsetty, kinda nice. We turn on some motion capture. We see our astronaut here running around and getting shot or something similar, falling over. We can just play the animation, and we even have a camera set up which we can choose like this. The background blur doesn't work now, so let's turn that off. There we go. And here we have something which we can make some kind of decision from already. We can play with the color to make it look more sunsetty. Maybe this is across the lake from the battle robot we're just doing, who knows. But yeah, look dev straight in the viewport. If we stop on a frame, we can just look around and see the space expanse around our guy. It's looking pretty nice. Let's see if we can compare it to rendering again. And yes, it looks pretty much identical. Since the physical materials shading in the viewport is very similar to what a game engine does anyway, we can actually use materials that are intended for game engines and they will look the same. We've actually created two specific extra materials for that purpose. Now, these are just front ends to the physical material. They are scripted, and you could actually use them and template them to use your own. Supporting two of the known PBR models, the metalness roughness and the spec gloss model. So if you want to use this, you can simply go to a site like freepbr.com, pick out some interesting material like this rusty kind of metal thing. You download the files, the ones for Unreal tend to work, and then you just need to put in some environment in your scene, important for reflections to look good. You take the PBR metal roughness, you apply it to your object. Then you drag drop your textures in. Your base color, your metalness, your normal and your roughness, and you are done. It looks exactly like it would in the engine, and of course in the rendering. You might recall I made a tutorial using this gun from my good friend Sergio Santos. It was about a half-an-hour tutorial how to set up PBR materials. Well, it's a lot simpler than half an hour now. Make sure you have an environment map, drag in your PBR material in metalness roughness mode, assign it to your objects, and then we start drag dropping textures. We don't have to think about anything about gamma, it's all automatic. We just drop our AO here, base color there, emissive here, the height we don't use, the metalness goes there, the normal goes here, and roughness goes there. Boom. Done. Was that half a minute? 60 times faster. Turning on depth of field or rendering, well, No surprises there. Continuing on the mindset of look deving with the viewport, we have another cool feature that we added as a form of OSL shader. Here we have a Buddha statue which is lit by an environment as we've seen before, but let's tone down the environment and try something different. I'm going to drop in a shader called HDRI Lights and connect it to the additional light input of the environment. I'm going to pick a reflective umbrella picture, which is a picture of a light source. I can put in some position and this will now look as if that light was coming from there. If I push this button, I get a point helper. I can actually move around and move from where the light is coming. Actually, I can even dig up the old Mac's place highlight feature and click on my object and literally place the highlight or the reflection of this light where I want, so I can sculpt with light in a very elegant way. If we zoom in, we'll see the reflection of this umbrella reflector. We can change the size of the light. We can change, of course, how bright it is, and we can tweak the color temperature and stuff like this. We can rotate it, etc. Now, if we check this little box, it will make it also visible to the camera. So there we see it. We can grab the point helper and drag it around, or do all the other tweaks. But you normally don't really have it there. You look for its effect on the object. Basically, you can do light design now completely in the viewport live. You're building an environment map from images of other lights. Here I'm putting in a different rectangular light. The place highlight feature is really cool for that. You can make it brighter, you can make it bigger, etc., etc. Now note, these are not really lights, they are pictures of lights in the environment, but we can see that the renderer on the right will of course generate a shadow based on it correctly. The viewport currently doesn't, but that is because we have progressive skylight off. If we turn that on, even the viewport can do this. So it's a trade-off. If you want the accurate shadows in the viewport, then you would use progressive skylight turned on. If you want to avoid the flickering and have it look nicer, then you would have it off. It's completely up to you. Also, there is now a slider where you can set the fade-in speed of the progressive effect. So you can choose between it fading in slowly and being all nice and non-distractive, or fading in quickly so you see the shadow immediately. Some general improvements of OSL shaders. First of all, we changed the categorization a little because we now have 126 OSL maps, so keeping them in order is pretty important. For instance, the math groups are now one level higher instead of nested, which was a user request. Also, UI can be dynamic. The automatic UI has some features to, for instance, in this case, add or remove stuff. Also, some shaders have a custom built UI. This is all Qt, so this is hand built in Qt Designer. It's a .ui file. Same here, instead of just using the automatic UI. Shaders can also decide how many outputs they expose in the node editor. Of course, the ultimate custom UI is this one. There's a curves shader now, which can use both as creating gradients or actually like a color correction feature, kind of what you have in Photoshop. And speaking of color correction, we have kind of the ultimate color correction shader thrown in. From trivial stuff like brightness, contrast, and similar, it can of course tweak hues and saturation and stuff like that, do tinting. There's a tritone tinting mode where you can set your highlight, midtone and shadow color. It has options to flip around channels, like here we invert the red, or we can invert the entire color if we want that. There's even a feature where we can apply the entire effect to only a certain hue, like I'm picking here the shirt of the girl, and now that's the only thing, that hue range is the only thing color corrected. Quite powerful. Next we include some camera projection shaders. Here's one free camera which is projecting a texture onto the object. We can switch if we want it to project through or only on the front side of the object. It works with any kind of camera. Here I plug in another one and use a physical camera. Again with the dynamic feature, so you can have object pick buttons in OSL shaders now to pick stuff like cameras. If you change the field of view, it follows. But important is the aspect ratio is custom set here, and unlike the old max per pixel camera map, it doesn't care about the aspect ratio of the rendering. There's also an object projector where we can pick this dummy cube here. We can set a size and it will project simply in the XY plane of that cube, so not a perspective projection but a flat one. We can pick a different, here's a YZ plane. And of course, if we scale the object, it will scale like this. So you can use this for projective texture mapping in all sorts of interesting ways. Finally, there's a spherical projector. So if we pick this other dummy cube, it will project spherically from it. This can be useful if you want to project an HDRI environment map back onto geometry to build like dummy geometry for shadow catching and similar. Of course, it works exactly the same in the render. I've said that a few times now, haven't I? And finally, procedural noise. There's an uber noise shader which has all sorts of mode, various whirly noises, purlin, etc, etc. It has features like distorting the layers in the fractal. It can apply step functions within the fractal cascade or globally. It has two colors to simplify not having to plug it into a interpolation shader. You can do multiplicative or additive stacking in the fractal stack, and so on and so on. And of course runs completely procedural in the viewport, so it updates in real time and looks exactly like the rendering. It's especially fun when you apply it as a bump map to get all sorts of wrinkles and wiggles and other kinds of effects. So I hope you enjoyed the additions we had in Max 2021, and zap out. Bye bye.